Hi everyone, welcome back to my channel. This is Mr. Budejas, your online math teacher. In today's video, you will learn the circle and its parts. Let's start with the definition of a circle. Circle is a set of all points on a given plane that is equidistant from a fixed point on a plane called the center of the circle. This is now an example of the set of all points that are equidistant from a fixed point called the center. When you say equidistant, that is of equal distance from a fixed point to any point on the circle. We are going to name the circle based on the letter used to indicate the center of the circle. For example, the circle here is named circle C because the fixed point or the center is point C. And we are going to use that letter as our name for the circle. Again, this is circle C. Second, we have radius. This is the distance between the center of the circle and a point on the circle. The plural form of radius is radii. For example, the line segment QC, line segment RC, and line segment PC are the radii of circle C. These are the three radii of circle C. Third, chord. A chord is a line segment whose endpoints lie on the circle. For example, the line segment QR, line segment PR, and line segment QP are the chords of a circle C. Because these are the line segment and whose endpoints are lying on the circle. The endpoints of QR or line segment QR is lying on the circle. And the same thing with line segment PR and line segment QP. Number 4, diameter. It is a chord that passes through the center of the circle. If a chord passes through the center of the circle, that's a diameter. And take note that the diameter is also the longest chord in a circle. For example, the line segment QS is the diameter of circle C because it passes through the center. Number 5, secant line. It is a line that intersects a circle in 2 points. We have 2 lines here. First, the line QS. Second, line QR. Line QS is a secant line because there are 2 points of intersection, point Q and point S. And for line QR, that's also a secant line because there are 2 intersection points on a line and on the circle. The line and the circle. So the points are Q and R. Next, we have tangent line. It is a line that intersects a circle at exactly 1 point. And the point where it intersects the circle is called the point of tangency. For example, the line UV is tangent to circle C, and the point of tangency is point T. This is a tangent line because it intersects the circle at exactly 1 point only. Number 7, we have arc. It is a portion of circle formed between 2 points on the circle. Take note, we have 2 arcs. First is the minor arc, which is the measurement is less than 180 degrees. And second, the major arc, the measure is greater than 180 degrees. For example, the arc PQ is a minor arc because it measures less than 180 degrees, and the arc PRQ is a major arc because the measurement of that is greater than 180 degrees. Number 8, arc addition postulate. This postulate states that the measure of an arc formed by two adjacent arcs of the same circle is equal to the sum of the measures of the two arcs. For example, in the given circle O, measure arc QP is equal to 90 degrees and measure arc PR is equal to 120 degrees. These two arcs, QP and PR, are the two adjacent arcs. The sum of these two arcs is equal to QPR. Here, QP is equal to 90 degrees and PR is equal to 120 degrees. Just add them. 90 plus 120 is equal to 210. Therefore, this measure arc QPR is equal to 210. That's arc addition postulate. Number 9, central angle. It is an angle whose vertex is the center of the circle. So the vertex of this angle is at the center. That's a central angle. The keyword there is center. For example, in the figure to the right, this one, angle QOP is a central angle because the vertex can be found at the center. So this QOP is what we call the central angle. Number 10, central angle postulate. The measure of a central angle is equal to the measure of its intercepted arc. So since this is a central angle, QOP, the intercepted arc is arc QP. This is the intercepted arc. So whatever the measurement of this central angle here is also the measurement of its intercepted arc. For example, the measure of the central angle QOP is 90 degrees. It follows that the measure of arc QP or the intercepted arc QP is also 90 degrees. That's central angle postulate. Number 11, inscribed angle. It is an angle whose vertex is on the circle. For example, in the figure, angle QRP or PRQ is an inscribed angle because the vertex can be found on the circle. Again, this is an inscribed angle because the vertex is on the circle. Now let's try some examples about the parts of a circle. Number 1, name the following parts of circle O given below. From A to J, we need to identify what parts of a circle are they. So the solutions are, for letter A, line segment OC is connecting the center O to the point of a circle which is C. Therefore, this line segment OC is a radius. For letter B, line segment AC is connecting 2 points of a circle which is A and C. And this line segment passes through the center O. Therefore, this line segment is a diameter. Letter C, line segment AD. This line segment connecting 2 points of a circle, which is A and D, but does not pass through the center O. Therefore, this line segment AD is just a chord. Letter D. Line AF. Line AF is a line which intersects the center at exactly 2 points. We have A and B. These are the two intersection points of a line and the circle. Therefore, since there are two intersection points, this line is a secant line. Letter E. Line CF. Line CF is a line which intersects the circle at 1 point, which is point C. This point is what we call the point of tangency. Therefore, this line here, line CF, is what we call the tangent line because it has only one intersection point, which is point C. Letter F. Angle ADB. An angle ADB is an angle whose vertex lies on the circle. The vertex, which is letter D, is at the circle. Therefore, this angle ADB is an inscribed angle. Letter G. Angle AOE is an angle whose vertex is on the center of the circle. Therefore, angle AOE is a central angle. Letter H. Arc AC. Arc AC is an arc bounded by the points E and C. Its measure is less than 180 degrees. Therefore, arc AC is a minor arc. Letter I. Arc AEB. Arc AEB is an arc bounded by the points A and B and passes through E. Its measure is more than 180 degrees by just merely looking at the given figure. So this is greater than or more than 180 degrees. Therefore, arc AEB is a major arc. Lastly, we have arc AC. Arc AC is bounded by points A and C. Since arc AC or line segment AC is a diameter, it follows that arc AC is a semicircle. Example number 2. In the figure below, measure angle BOC is equal to 60 degrees and measure angle AOB is equal to 135 degrees. Find measure arc AC. Here's the solution. We will use the central angle postulate to determine the measure arc AC. This postulate states that the measure of a central angle is equal to the measure of its intercepted arc. Since measure angle BOC is equal to 60 degrees, it follows that arc BC is also 60 degrees. And since angle AOB is equal to 135 degrees, it follows that its intercepted arc AB is also 135 degrees. So you have 60 here and this is 135. Remember that the measure of the arc equivalent to an entire circle is 360 degrees. Thus, we can add the measures of the three arcs and make it equal to 360 degrees. Measure arc AB rather, plus measure arc BC plus measure arc AC is equal to 360 degrees. That's the entire circle. Now solving for measure arc AC, just add the three arcs, equate it to 360 degrees, and then substitute the values for arc AB, that is 135 degrees, and for arc BC is 60 degrees. And we don't know yet what is the measure for arc AC, so let it be unknown. 135 plus 60 degrees is equal to 195 degrees plus the measure arc AC is equal to 360 degrees. Now combining like terms, 195 degrees is a constant term. We will transpose it to the other side and it becomes negative 195. So 360 degrees minus 195 is equal to 165 degrees. And that's the measurement for measure arc AC. And that ends my discussion for today. And now I want you to answer these two problems under individual practice. Number one is this, and second problem is this. And I want you to comment your answers below, and so that I can check if your answers are correct. And that's all for today. Thank you for watching.